All right, it's just past midnight here in Washington, D.C., which means I've probably started the clock on the new Claude weekly limits. This is going to be a big change for me because I'm on the Claude Max plan, $200 a month, and that $200 has bought me almost $6,000 of API credits in the past month. So I'm using Claude Code a lot. I'm hopeful that there's still a couple hours before this actually goes into effect, Pacific time, but I'm going to, regardless, sort of use some of these tokens to show you how we're using custom slash commands and subagents to make more accurate models of the tax and benefit policies here at PolicyEngine. So to cut to the chase, we've got this new encode-policy slash command. Text is here on the right. I'll show that in a minute. And you can just plug in the program you're looking to model. So in this case, we're going to model Texas LIHEAP. So that's a low-income home energy assistance program. I've never looked into this program's details. I'm familiar with LIHEAP in some other states, but we've never done anything with Texas LIHEAP before. So this is going to be from scratch, lots of different phases, and including test-driven development in a way that we hoped we could do with humans for a long time, but we didn't quite get it working, and now I think subagents actually open up a new opportunity there. So the first phase is an issue manager. This is a pretty small subagent. It's really just trying to check if we already have an issue for it. If we don't have an issue, we're going to create the issue. Okay, so this should be pretty quick. Once we've got the issue number, we've got the URL, it's actually going to create a draft PR early as well. Okay, we're back, and now we've got our second agent here, which is the naming coordinator. This is just going to figure out what the best name is for this new variable. And we're looking for Texas LIHEAP. There are other LIHEAP variables, so this should be an easy one for it to figure out. But we can actually look at that naming coordinator file. So here's the way these subagents work. You've got some front matter that indicates what it can do, what the model is for it to use, and then a whole description of what its tasks are. Okay, so that's done. We've got our GitHub issue. The issue now has a new comment with the naming from the naming coordinator, and now we're moving on to some of the more substantive work. So this is actually collecting all the documents. These would be the statutes, regulations, program manuals for the LIHEAP program in Texas. And what it's going to do is invoke our agent to grab the official documentation and, again, post it to the GitHub issue that we already have. So I'll just pull this in here so you can see. And this is the issue. So we started off with the first one, just figuring out, do we have this issue already? We've got some information about it as well. And now a second one is kind of overkill for variable naming convention, but we've got all the potential variables that we might want in the system. And now the second or the third thing is going to be pulling that in to based on the documents that are available. So this takes a little bit longer, but I can show you the document collector. Which is right here. So we're looking for really authoritative primary sources. So these are not supposed to be secondary government sources. Okay. As close to statutes, regulations as possible, and then manuals usually are the ones that fill in the gaps. Sometimes you need to get information from other secondary sources as well, but we really try to avoid that. And we sort of have that hierarchy of preference here as well. Okay, so it's going to grab the files in certain formats. We're looking to store this in more of a database kind of structure in the future because a lot of these documents, they're not always available forever. So, but for now, we're just sort of putting in the URLs of everything that we're grabbing, and then it's going to add those over to the Markdown file. All right, we're back, and the document collector is done, and now we've got the test creator and the rules engineer operating at the same time. So this is, they're operating actually in separate work trees, Git work trees, so they can't easily, they really have to work to see what the other is doing here, which is exactly what we want. We want the test creator to be building the integration tests, looking at the forms and trying to fill it out from scratch, independently of the rules engineer who's actually trying to put those documents into a system that can generate the code for lots of these examples. So this has been, I think, the most exciting piece of this to us. And we can see, if we go into encode policy, sort of how this is working. So you've got to be a little bit explicit here, but we're basically calling the test creator and rules engineer. We're saying to do this in parallel, and really that's enough to make it work. So this should be in separate conversations, and they're actually going to have different branches. So, and we can look at test creator. So test creator, this is getting a new work tree set up in Git. And then it's going to look at all the documents which are now in the Git repository or the GitHub issue. And it's going to pull in, various types of households to really get good coverage of the integration tests. So we're not going to merge it. We're just going to have the branches, and then we're going to synthesize those after it's done. Now the rules engineer also has its own Git work tree, and it's also going to look at the same documents, and it has enough access and sort of understands our code base well enough that it can start to bring in the rules in, for example, we have parameter files as YAML files. All the policy parameters are represented there, and then the logic is represented in Python, basically NumPy operations through different variables. And once it's done, it's going to commit, and the main thing it's trying to do is bring in the input variables, turn them into the output variable, the Texas LIHEAP, through whatever intermediate calculations it needs to do. Okay, so this will take a while, but by the end of this, we will also have the opportunity for it to bring in those branches and do a variety of tests. So it's going to do even more sort of checks, verification that we, validating lint, making sure that it is doing edge cases correctly, checking different cross programs, sort of categorical eligibility type procedures correctly, making sure the documentation is as good as possible, that there's things like we need this to be vectorized so that it operates over microdata for the microsimulation. And finally, it's going to, after all this is done, do a final review and then push it to a draft PR and check that the continuous integration CI/CD pipeline all passes as well. So I haven't actually counted the total number of agents. This is something that's been a work in progress. We're still evaluating, doing different experiments to have different versions of this. But this seems extremely powerful, and especially now that we are going to have some more limits in place. This is also a way to save on tokens, because each of these individual agents operates in its own context window. So you're saving you'd otherwise have to pass all of your previous context into the window. So this is going to actually, I think save us money, but also more importantly, improve the speed and accuracy of our execution. So hope you enjoy using these custom slash commands and sub agents. It's extremely powerful technology. Cheers.